Hello, everyone. Thank you for joining us. We're here today to discuss the challenges and solutions surrounding AI and big data. We have with us today Hub Security's very own CRO, David Hochhauser, alongside a number of amazing industry experts, including Nitin Aggarwal, Priyanka, Telang, Doron, Reuter, Dr. Sanjeev, Chaube, and Sidharth Kumar. Thank you all for being with us today. We'll kick off our webinar with a brief introduction from David Hochhauser, and then we'll allow panelists to each briefly introduce themselves. Afterwards, we'll get into a bit deeper discussion about AI and big data, including challenges, solutions, and of course, cybersecurity. And like always, we leave time at the end at the end of our discussion for a short Q&A. If you have any questions throughout the discussion, feel free to drop them below in the Q&A section, and we'll get to them later on. Now we have an impressive lineup of panelists tonight, and we're really excited to have all of them introduce themselves. But we'll start with a few words from David Hochhauser, Chief Revenue Officer for Hub Security, and then we'll follow up with the panelists. David, go ahead.
Okay, hey, thanks, Doron. I said I'm Dave Hochhauser, the Chief Revenue Officer for Hub Security. And just briefly, so we're a cybersecurity company that we design extremely secure computing platforms. And I just want to welcome everyone to what I think will be a fascinating discussion. I just want to take my 2 minutes to explain kind of why we're holding this session. And then we'll keep most of the session focused on our expert guests on AI and machine learning, and some thoughts around security around such services as well. So why did we convene a session with these experts on AI and big data? And first of all, to begin with, AI has massive potential. It's just game-changing technology that's coming on very strong. And it's also fueled by a number of other related technologies and innovations going on in IoT, 5G, edge and cloud computing, along with a lot of industry-specific innovation in each of those technologies. And so what you're seeing is the amount of information and computing power from all these technologies is exploding. So you have 5G bringing data faster. You have IoT bringing more of it from new sources from all over the place. And you have cloud and edge computing, and what's happening there is the computing literally will be everywhere it's needed. And I've seen estimates that predict, over 50% of all computing power will actually be at the edge going forward. Now, underneath all that, so you have all this computing power, all this information. So what you have now is AI and machine learning making sense of all of this information. Literally, it's too difficult, obviously, for humans, but they're actually making sense of all of it. And that's what's contributing a lot to all of this drive in AI. And just from a security perspective, since, that's my area of focus, this whole rapid pace of new technology coming together is bringing rapidly increasing security and privacy threats. And they really do require entirely new cybersecurity approaches to deal with them and protect it. So I'll give you an idea of the pace of change and what's happening. I've seen projections of spending on AI that it shows the market is at $27 billion in 2020. And it's growing to 267 billion within a few years by 27, which is a phenomenal growth. So that's really what's driving the interest and why we're focusing on AI. And so kind of to make sense of it all, we've put together a panel, and we'll really break the discussion kind of in 3 general categories. So we'll talk about AI as a whole in the market, the overview, what are some of the specific industries and trends going on, some of the challenges and the different approaches and solutions to AI, as well as some of the cybersecurity considerations that are around it. So hopefully everybody sit back and enjoy. And back to you, Doron.
Thank you, David. That was a great start. In addition, we'll start a quick round of introductions. I think we'll start with Nitin. Would you mind giving our listener a bit of background on yourself and your expertise? Go ahead.
Absolutely, Doron. Hey everyone, thank you so much, and thank you so much for having me here. I'm Nitin Aggarwal. I'm currently leading Cloud AI Industry Solution Services team for Google Cloud. I'm based out in Bangalore, India. I'm in this domain for AI for almost a decade. I'm at Google for last 6 years. My team is actually responsible for building AI ML based custom solutions for our strategic customers at Google Cloud. So we work with the Fortune 500 industry, ranging from manufacturing, industrial to healthcare. So yeah, definitely, I'm looking forward to this conversation with all the experts.
Thank you, Nitin. We're looking forward to hearing more from you down the discussion. Priyanka, if you can continue, that'd be great.
Yeah, thank you. Hi, everyone. I'm Priyanka Telang, and I am an AI solutions architect and a technical leader in the Insights and Intelligence Labs in IBM Software Labs India. And I have almost 2 decades of experience around various web technologies, development on cloud and AI since the last 5 years. And primarily for all my experience, I've been working with the supply chain organizations of the world and building omni-channel experiences for them and inventory visibility solutions on the IBM supply chain platform. And currently, I'm leading the infusion of AI and automation technologies into the supply chain to basically build self-correcting and resilient supply chains. And of course, I've always been passionate to learn more and give back, to the data and AI community with regular lectures and talks like this. So I am thrilled to be here. Thank you.
Thank you, Priyanka. Great to have you with us. Sidharth, if you can continue, that'd be great.
Hey guys, good to be here, and it's a pleasure to be amongst elite crowd of panelists and attendees. I'm Sidharth. I basically started off, with my PhD in astrophysics, and then moved on to doing data science and human capital management. I also am fascinated by a lot of things in trading, so I basically then jumped on to trading. And then right now, basically moved on to e-commerce, and then I'm at Intuit currently, right? Now, so basically you would just look at my background and say, okay, this guy is jumping all over the place. But I'll give you one thing to say, which is that I have essentially done only one thing, which is data science. I've done data science all my life. The common thread is computing, statistics, machine learning, and computer science, right? So essentially, the whole point is everything comes together with large-scale computing, with complex models. And this was back in sometime in 2015 when I started off this whole process of applying machine learning to astrophysics. And then here I am today, deploying billions of models every day on AWS. I am running my company quite a bit on that, but that's a discussion for another day. But excellent to be here. I am very interested as to how the different fields are being contributed to by data science and cybersecurity as well. So pleasure and thank you.
Pleasure is ours. Thank you, Sidharth. Doron, take it away.
There we go. Hi, my name is Doron Reuter. It's nice to be here with you all. Thanks for the invitation. I am a director within ING's Global Analytics Group. ING is a big Dutch bank. If you've never heard of it, it's one of the top 40 banks in the world. It's based in the Netherlands, but has offices in about 40 different countries around the world. My latest endeavor is an exciting venture which uses cutting edge AI in the application security space. I'm predominantly busy with that today. For the last 7 years within ING Analytics, I have been part of the core team that scaled the capability within our wholesale bank, going from about 5 people to 130 people, delivering digital products with embedded machine learning for the use by ING people within ING's wholesale bank and our ING wholesale banking clients. And that's the division of ING which serves corporate and institutions. So thank you for having me.
Thank you. Second one, Sanjeev, please.
Yeah, sure. Thank you so much, Doron, sorry, I got your name correctly. That's right. Okay,
Yeah.
wonderful. So thanks for having me here on the discussion on the panel. Right. Thank you to the Hub Security team and the panelists and the viewers who are part of this particular discussion. So I am Dr. Sanjeev Chaube. I head the Big Data and Advanced Analytics practice, basically AI and data science for Vodafone Idea Limited Pan India. Right. So that's so within Vodafone there are different challenges with respect to customer marketing, analytics, right, and identifying different kind of performing different predictive and advanced analytics in terms of identifying who are the customers, what products can be offered, or what how do we identify the pain areas of a customer, how do we identify the sentiments of the customer. So using different kind of structured and unstructured data formats to basically identify, predict, do different kind of segmentations, some kind of predictive recommendation, ultimately focusing on the customer experience and the profitability of the organization. These are the two factors that we generally look at when we look at making any AI/ML model, because that's the strategy, right? So how do you use AI/ML model to generate a revenue for the organization or save the cost or operational efficiency, right? Different models that you make basically emerge from these requirements. So this is what we do. We build different kind of predictive models, advanced analytics models to support organizational strategy. So thank you so much again for having me here.
Thank you all for the introductions. We'll move to the next step and then start a discussion with kind of a broad overview of AI market and some technology overview. Sidharth, I would like to start with you. I'd like to ask how do applications of machine learning vary across fields? If you can also share a few examples, that would be great.
Absolutely. So one of the things that I have had the pleasure of doing is to apply machine learning to about 7 different fields over my work life, if you want to call it that. And this includes things like e-commerce, finance, fintech, supply chain optimization, pricing, personal finance, which is current, and then before that, human capital management and astrophysics. So this is basically so one thing that I take away is that all of them have a lot of data. What do you use the machine learning for, right? And so essentially, how do you apply? Now, if I so essentially one thing is just to reiterate one thing to start with, which is finance, right? Let's take a very, very interesting problem, which is trade, right? Everybody wants to predict the stock market, right? And people are asking how do you use machine learning to do that? Fantastic problem, right? But also one should not overfit, and then one should not use future information, and then one should not use too much information so that it doesn't become stale. Too little information because it won't be enough signal to noise. So you basically are stuck with a dilemma, and so much so that you're like, okay, I'm going to shelve machine learning and go to use one of the ARIMA models of that. Right? It's like just a plain vanilla time series model. But what we discovered is that there are ways to get around over parameterization, which are now, right? For example, very, very important in cases of finance. So you basically have to get it down to the wire as to what variables are important, for example, right? Now, there are also problems, for example, in say, computer vision, in speech, for example, right, where you are using deep learning. Deep learning is fantastic where over-parameterization is okay. In fact, it's a desirable consequence to have overfit in those cases, right? So you're like, okay, I have this redundancy. I'm going to predict that a cat looks like a cat, a dog looks like a dog. And then you can't bring that over to finance very easily, because then you're going to start overfitting those time series, right? Now, the thing is that it's not just about the choices of algorithms and so on, but also what do you do in different fields? Because I think the deal is that you are essentially, each of those fields has a different need. So some of them need forecasting, some of them need clustering, some of them need things like, just give me an idea of reinforcement learning in order to target better and so on. So the whole point is that you need to find out what is the maximum ROI that you can get by using any machine learning. Right. The thing is that I think that is one of the most primary problems in industry, which is that I think a lot of companies jump in saying, I want AI, right? It's like it's a blanket statement. So bring the guys in, and it's basically let's see how we can apply AI. But the thing is, I think defining those problems beforehand is super important, and then what it can solve, what can be used to solve it, and essentially, is it worth the computational time? Now, I'll give you some examples of cases where people are like, I'm going to explore everything and then come back to basic statistics. It's like the last model that they use will be a linear regression or a basic statistical model. Why? Because it's computationally efficient. It's not overfitting. And the key mantra today is something called explainable AI, right? Now, you take a more complex model, explainability just goes out of the window. It's not that easy, right? I mean, you have things like Shapley and so on, which can help with that. But essentially, you are kind of like, simpler is better, and then you work your way from there. So my only takeaway from this point on, essentially, if I had to kind of summarize one thing here, is that I think you need to use the right hammer for the right nail. And I think that is something that takes time. And, essentially defining what the hammer is, what the nail is, and what the problem is are all super important. I know that the answer that I have given just now seems a little bit vague, but I think the generalizing across fields is actually quite a very tedious task, I would say, which requires a little more time. And I would like to give other panelists time as well to answer that question. So thank you. I hope I have done some justice to your question.
Thank you, Sidharth. Actually, to continue, one thing you said about supply chain, Priyanka, if you can continue here, but how AI is being used in the supply chain domain. If also you can share some examples from your experience on AI and data science would be great.
Sure, Doron. So I think we all came to know about supply chain, and people who didn't know about, what it was, we all came to know during the pandemic. I think most of the supply chains actually crippled during the pandemic, and everybody seemed to be realizing that, they need to be very efficient and resilient. And actually, it's very complex. So if you actually see the journey of a product from a manufacturing to the delivery to the customer, to the end customer, it actually has a lot of moving parts, a lot of systems that are working at the back end. And primarily of the last 15 years that I've been talking to the different supply chain organizations, they have usual traditional methods to actually keep track of the supply chain. So they are totally based on hard-coded rules, and they are not really backed by real data. So all the traditional methods and the rules that have been existent for past so many years have actually failed during the pandemic. And that is where people got the direction and wanted to start using data and AI and machine learning that would really help unlock these insights from the complex world of supply chain, and go into a lot of predictions, like managing out of stock by getting predictions, better ways to do demand forecasting, predicting supplier delays and supplier risks, and all these, right? So AI and machine learning actually forms a key part in using that data of the supply chain that kind of lies across multiple systems and unlocking the insights using these predictions. The current trend basically in the traditional demand forecasting is basically using the active demand forecasting, which is dependent on a lot of external factors. So traditionally, they've always been based on historical data that have been used for reporting and analytical purpose. But the current trend is actually infusing the events like market trends, the pricing, the supplier risks, and even real-time events like political strikes or labor strikes, traffic jams, vehicle breakdowns. All of those events actually impact the supply chain operation, and using AI and machine learning models is kind of the key to solving these problems, to understand the impact of all these parameters that play an important role in defining what happens in your supply chain. So basically, I have been working to infuse these machine learning models into the supply chain systems. And the second thing I would say is also, which is a trend right now, is to basically use heuristics and all the domain knowledge that we have developed till now, the humans have developed, to transfer that to the machines, using the ontology definitions, um, and also skilling the or adding the skills to the natural language models and an assistant to understand, to make sense of all this data, and the basic interconnection between these supply chain entities, like how the order is actually interconnected to inventory, and how the customer is at the center of the entire supply chain, and how customer will get impacted due to any delays in the inbound shipments, or anything like that. So the ontology definition and the graph neural networks are used to kind of understand these links and play a great role, in building the recommendation models, and also, takes us towards a self-correcting supply chain. So those are the different applications that I've been working on, Doron.
Oh, sounds very interesting. Thank you. Nitin, if you can follow up here and help us understand a bit more about main challenges for scaling with AI, and why in some cases it's not working.
That's a good question to start with, Doron. I think Sidharth and Priyanka covered a lot, many of use cases that what we can actually solve using data science and AI. In my experience, what I found that, okay, and even McKinsey and Forbes recently published a few of their articles that less than 50% of unstructured data is being actually used in decision making. And the second one is that, okay, more than 80 to 85% of the models never sees the life of the production environment, like they just end after the experimentation. When we read those two papers in parallel, and based on my experience, what I found that, okay, Doron, whenever we start working on AI, we never start thinking from scale. We think that, okay, hey, let's solve this small problem, sort it out, and then we can talk about the scalability later on. But that's not how AI works. Majority of the times, what we have seen that, okay, developers, engineers, product managers, or even the management, they are habituated of creating very deterministic systems. For example, A plus B is equals to C, 2 plus 2 is equals to 4. So in this case, it's like these kind of systems scale up linearly. Like you have one CPU, one GPU, or a one TPU. Just keep adding more CPUs, and you will be getting more processing power, more computing power, and scalability will be handled. But in the case of probabilistic system, where we are talking about AI and ML, this kind of a linear fashion never works out. It's not like that, okay, hey, if you can run a model on one CPU, if you're going to add one more CPU, more machines, more computing power, you will be able to scale things up. No, it will not work out like that. You need to think even from the scratch that, yes, how you are going to solve that particular problem. You have to think at a scale that, yes, what kind of a scale that you are going to target, and what kind of a things that you're going to solve it out. The second point is, Doron, like in my experience, what I found that, okay, AI is almost just like what I should say, a leverage that you have till you have that knowledge, until you have that particular algorithm with you, and rest of all does not have it. I can give an example. Think about Amazon or like a Google. They have a recommendation system on YouTube. Now you expect that, okay, you're having a recommendation engine everywhere, whether you're going to Bloomingdale's, Macy's, Tata Group, like any website. When you start typing something, you should start getting the right output, and you should be recommending the right things to you. So now creating that particular AI framework will not going to give you any competitive advantage. So solving that particular problem, it's not going to make sense. That problem has already been solved at scale. Take that solution, take that problem, tweak it as per your needs, and directly use it. So Doron, I think we can discuss this topic for only 4 hours. But my understanding is that, okay, if you are solving a problem at scale, think at scale, And if you're not doing that, we are actually solving the wrong problem, and we can actually see the business impact later on. And that's why scaling the AI is not about just computation. It's not just about algorithms. It's about scaling the thought process of the people who are designing it, who are envisioning it, and who are building strategies around it.
Thank you. I agree on the scale, and I would like to follow up with that. Sanjeev, you can help us understand better about the value proposition of artificial intelligence and machine learning for enterprises. I think would be a great continue to Nitin's input here.
Absolutely, Doron. I think well said. I think Nitin also said certain things, garbage in, garbage out, data drift problem is always there, right? So whether we build models on a smaller data sets, and when we start scaling them on a larger data set to the tune of terabytes or petabytes, certainly we understand. So before going to the problem, I also want to just give a kind of a view as to what customer is doing today, right? We need to understand. We recently tested one of the this thing, 26 gigabytes spectrum band that we tested for 5G in Pune, and that is Vodafone Idea Limited I'm talking about. And the speed that we got was 4.2 Gbps. Imagine what is the kind of data that we are going to get. 100 Mbps is something that more than 95% people are enjoying right today. And the data volume of data that we are experiencing already, right? So that also we call it as a big data, right? Imagine when the kind of structured and unstructured data which will flow through the network in terms of images, videos, the social media tweets, or different kind of usage patterns that will emerge now. So because the customer touch points also have increased, right? So there are so many touch points, so many type of data, so many variety of applications today a consumer is using, right? Today everything has gone to the mobile part, right? So what are we? So that's why I'm just trying to connect the enterprise part and the consumer part. So enterprise, when we're talking about enterprise, I take mobile as one of the edge devices, right? Where we can integrate or embed a lot of intelligence, right? And that can be utilized and leveraged by both consumer as well as enterprise, right? We can have these kind of use cases, and I can talk about those use cases. Very straightforward. So a lot of applications, as Nitin and Sidharth, Priyanka said, a lot of use cases are already available in the market, open source market, right, for consumer to use. But if you want to really make them enterprise version, I think we need to really bring in some very differential competitive advantage to the use case or to the application that we are building on top of AI/ML, right? And that's why when we are talking about enterprise, talking about consumer, or talking about IoT devices, especially I'm talking about. So if we are talking about IoT devices within enterprise, and on the other side, the consumer, the volume of data is increasing, right? If we talk about the overall telecom industry, I think today, the kind of calls or the CDRs that are generated, called detailed record, it would be massive. It would be very huge. I think roughly we can talk about 10 to 12 billions of CDRs that are generated every day across telecom industry. I'm talking about top 3 players, right? So look at this kind of scale of data that is coming. Now building on top of this volume of data, different predictive models, right? So be it classification related model, recommendation, anomaly detection, or identifying where the networks are failing, right? And that too on the real-time basis. So these are the challenges which we generally face, and the value that we bring in is, of course, I said, when we start the AI/ML model strategy, we understand, as Nitin also said, 80% of the projects, AI/ML projects, they don't see the production environment. That's right. Why? Because then the value proposition is not worked out very clearly, right? So if we understand that there is a cost involved to a particular project, what is the kind of cost we are going to save, what is the kind of revenue we are going to generate, and what is the kind of efficiency we can bring in, looking at the customer, right? Looking at the customer benefits. These all things, if we can bring in, we can certainly ask customer to pay a little extra. That's not, customer doesn't mind paying a little extra if you are providing that kind of service to the customer. So certainly these are the things, and then building different predictive models to make customers' life little easy in terms of maybe cross-selling, identifying cross-selling opportunities, upselling opportunities, right? Product recommendation opportunities, or identifying basis the text or basis the email. Just try to understand what is the kind of sentiment a particular customer has across region, across India, right? 270 million customers. I think 90% of the countries won't have that much population, how much customers we have today. So, and there are other telecom organizations within India itself who are having 450 million customers. So that's a huge base, right? And that's the kind of volume, and that's why these big data models, big data AIML models, they bring in these benefits in terms of revenue for the organization, customer experiences for the organization. I think it makes a certain difference, right? When we are trying to perform, we are trying to shift from plain descriptive analytics to predictive, and then going to prescriptive analytics, and then I'll say going to a preemptive kind of analytics, where we are actually identifying the fault before it is happening, fault detection, and so on and so forth. So these are my points, few points that I wanted to highlight basically.
Thank you. We'll definitely go deeper in the next parts of the discussion. Following talk about the scale and data science that was mentioned, maybe from another angle, Doron, if you can follow up and tell us a bit more about what's inspiring for you with the AI and analytics.
Yes, I think there's obviously a lot of developments and a lot of new things coming out, new innovations. I think the most inspiring for me are definitely happening in the area of natural language and video. I think there's tremendous amounts of innovation happening there at the moment. I think big technology companies are developing huge language models, and they're actually open sourcing these for general use with, sometimes I think up to the latest is 1 trillion different parameters being modeled. And I think that, costs tens, if not hundreds of millions to actually produce. And these are being made available to enthusiasts and innovators all around the world. And that is, a breeding ground for a tremendous amount of innovation, where, great minds with who are savvy and hungry get powered for free by, the technology shoulders of giants, to use it metaphorically. And I think we're going to see the same thing in video and in computer vision happening soon as well. I think that's the next big wave of that type of innovation. Or I hope at least it is. I don't know how the experience of these big tech companies have been, exposing language models, but I hope they continue to do that into video and image. So I think those for me are the most exciting developments. I think on the technology side, I also think that from a corporate or enterprise, I'm in the B2B space. So that's where I'm focusing most of my energy and time. So, I talk to that. I think what's exciting is that more and more traditional, so non-digital native enterprises are starting to scale their capabilities, starting to get in control of their data, starting to develop the people skills necessary, and starting to get in place the tooling, whether it's on-prem or through their use of, the acceleration in the cloud, to actually enable analytics product and AI product development, which is starting to get traction, and which is starting to yield results, and which is starting to truly change the way people use data in their decision making, or in their process, or in customer interactions. And I see that at ING, where we, after many years of growing our capability, are starting to develop processes, people skills, and tooling, which are starting to look more mature. And I expect, you know, an exciting development within the traditional enterprise like ING is that these will result in many more productive use cases and many more effective and personalized customer interaction.
Thank you, Doron. Moving forward, Nitin, I'd like to go back to you if you can help our audience learn more about more specific examples for industry segments, you know, from your expertise to talk about how artificial intelligence is evolving for specific segments. If you have a few examples, I think that'll be great.
Absolutely, absolutely, Doron. So, like, Doron, the first thing is about that's really interesting, and what I should say, very prominent is the maturity level across various industry verticals. And it's not just about the maturity level, but it's also about like regulations and compliance that you can actually see. So, for example, using deep learning or even a very sophisticated machine learning models in financial services or even in healthcare, in banking sector, it's very, very challenging because explainability or like explaining that particular model, getting the right validations from the compliance team and regulation is getting very, very challenging. So over there, you will see that, okay, even a very basic models like random forest, XGBoost, CatBoost, they are still their sweethearts. And we are solving some really fun problems using that. Credit risk scoring and preventing frauds and those kind of use cases are still prominent in these kind of industry. But now we have seen the shift from this kind of a behavior to a more sophisticated models, like automatically processing documents or creating or building chatbots for providing right customer services, and so on and so forth, like a lot many other use cases that we can envision. And the similar way in the healthcare, you can see like a lot of innovations are happening on medical imaging side, that yes, how we can predict lung cancer or even like a tuberculosis. The first of, I think, the foremost AI model approved by FDA to as a diagnostic tool, as a medical device, and so on and so forth. So I think now we can say that, okay, hey, those base models and everything that might go away, and we have to move forward with some more complex model with a pinch of salt that, okay, hey, you cannot explain everything. And if you're not understanding anything in detail, it doesn't mean that, okay, it's a garbage. You have to trust a few things at a certain point of the time. In the similar way, what we have seen like in manufacturing and industry verticals, yes, in predictive maintenance is one of the foremost use cases. Optimization is also an upcoming field for operational research. That yes, how can I build my maintenance plan, what to do, how much energy to build, when to sell, whom to sell, and so on and so forth. So there are like a lot of interesting use cases are coming in media and entertainment. I think Sanjeev is already here. I cannot touch that telecom. So he's the expert and he's the guru. But still, like even in the telecom, we can say that, okay, a lot many other use cases and interesting use cases might be coming up using these kind of technologies. But I think one thing it's prominent across that, okay, democratization of this particular technology and AI/ML, that's helping not just the industry, but also the experts. Now companies have started talking about that, okay, hey, I do not need skills who can build models. I need people who can actually work on the data, who has the right skills on these industry, on the domain, on the solution, and who can use my pre-trained model after tweaking the data. I do not need more data scientists. And I believe that, okay, in the future, there are going to be a whole range of what I should say, industry vertical specific scientist or a data scientist will come into the picture who can actually solve a problem instead of just like writing some random code and training a model.
Right. Thank you, Nitin. Before we go deeper into AI, David, from a cybersecurity perspective, what are the, and talking again about industries, from a cybersecurity point of view, what are some of the industries applications for AI that seems to have critical security requirements? I think if you can help us out.
Sure. First of all, these other ideas were very interesting. I'll tell you, the one that caught me kind of the funniest was Priyanka. I didn't realize, thinking about it, how much the pandemic highlighted to everybody the recognition of the job that you're working on. It just caught me as, wow, she just went from probably everybody looking at her that has no clue why you would be doing this to why that is one of the most important things somebody could, the effects of somebody. So just as a side, it caught me as funny while you were talking about that. My flip answer, Doron, on that is, hey, if it's worth developing an AI application, it's likely sufficient to protect it. But to be more specific, and I'm going to give you some examples of things that we've been looking at, and we've been focusing a lot on edge applications, both far edge and near edge types of applications. And some of the most critical things we're seeing is really dealing with critical infrastructure, which is actually more about 12, 14 different industries. And obviously the last month or so, the protection of that has been dramatically highlighted. But the things we're seeing and working with are things even that you don't think about as the food supply system. And there are actually over 2 million farms in the US alone, and I think there are about 50 billion farms on the planet. And you have things that you have drones automatically monitoring the fields for irrigation, automating tractors going out in order to, how do you make it more efficient and increase the food supply in the country? And a lot of these kinds of things that are monitored by AI, also the reason why a lot of them are at the edge is because they have a need for very rapid performance, low latency, and don't want to send huge information back and forth. Related somewhat to that infrastructure, even the power grid, just as one example, I mean, you could knock out 200 power stations in the US and knock out the entire power grid, and there's 55,000 stations here. And it's actually interesting because 38% of those are actually, of the attacks against the power grid are actually physical. So we see things like visual AI for surveillance and monitoring the critical infrastructure, whether it's water supply or pipeline, industrial plants, food supply. Seeing there's a whole range of AI, and I'm seeing personally visual AI is really critical area, and I know there's multiple aspects of visual AI behind that. Just as maybe one other example, in healthcare, seeing quite a bit, both from how do you, the data is critical in healthcare. So from a security perspective, that's why we're kind of involved in that perspective, not only protecting if it's doing AI for the individual devices, but really multi-party AI. Literally working on a pilot where people are taking AI information, they're taking data from multiple hospitals about MRI scans. And the more data you have, obviously, the more relevant and the outcome is going to be. But the issue is no one wants to share the data. It's extremely sensitive, and to de-identify it is a real hassle. And so from a security perspective, there are mechanisms to actually be able to people to share this information, maintain its privacy. No one can see it, but they could share the insights going out. And it's why that's a case of not only protecting it, but it also enables that kind of multi-party analytics without having to worry about exposing the information as well. So those are just a few of them. That along with, there are so many areas, but those are at least just a few of some of the ones that I'm seeing that from a security perspective are really popping up in our purview.
Thank you, David. Sure, we'll deal more with the privacy in the years to come, especially in healthcare, but probably in other segments as well. Before we move on to the more deeper discussion about challenges, just to remind everyone, you can leave us any question you want in the Q&A part below. And one other thing I would like to mention, this is actually the first discussion out of two. This is part one of AI and big data, and there will be another webinar following this one. I know some of the people are supposed to join both, so just a quick reminder. Happy to move to the more deeper part of the discussion, talk about a little bit about challenges, the different approaches, and of course solutions we have for AI, machine learning, and big data. Priyanka, I would like to start with you. If you can help us out with what challenges do you see in the adoption of AI in the supply chain, and elaborate as much as you can.
Sure, Doron. So Nitin talked about, data being very important to actually build domain-related models, right? And I think all the organizations and enterprises and businesses do want to, take on to the AI journey. But Where I have seen everybody struggle is just at the foundation, which is, the heart of AI is actually getting the right data. And if I have to talk about the supply chain world, where there are multiple disparate systems working together to make the supply chain work, which has diverse data sources, multi-cloud, hybrid cloud, and and distributed processes, and all of that data, if you see, it has to come together in such a way that it is easily accessible, and also, considering all the governance aspects of the data. So there should be good control over who can access that data and how it could be used, within the data privacy and the data confidentiality laws that are really strong these days. It is a big challenge in actually going on to the AI roadmap or the AI journey. So that's the biggest challenge. And I think the data fabric and the data virtualization kind of concepts, which kind of try to weave in all these different data sources onto a common platform, which is governed by rules and policies. I think that would be the base that we should work on. And the second thing that I talked about, getting all our domain knowledge and really passing it on to the machines to be able to understand that. So these two are the challenges even before, we could get AI and machine learning to do any work for us or generate any revenue for us or help us in any problems.
Thank you, Priyanka. Sidharth, how do you choose machine learning algorithm other than, for different various tasks?
Yeah, actually, so one of the things is I did touch on this before, right? And I did highlight that, for example, you would not use deep learning very commonly in finance, as you might not use, for example, a very simple thing like in random forest for a very large image classification problem. But generally speaking, right? Let's say that you have a task which basically has a different structure, a different set of data. So you should ask yourself the question first: what kind of data do you have? So let's say that you have image data, you have voice data, deep learning is perfect. Right? So there's a massive amounts of compute. But again, there is also the question of being diligent with the compute, because as I guess Doron was alluding to, there are all of these massive models which have been trained, right? And there is also this idea. I do see somebody saying there's this ecological impact which has come up, and David has said that, and it's a fantastic question because I am always worried about that, right? And I'm worried about it not just from an ecological standpoint, but also from the standpoint of being just a person who does not want to use too much when I can use little, right? So the question is, what is the right amount of complexity that the model actually needs? Now, the complexity that it needs. So essentially, say that it's I know deep learning has been extremely prominent of late. Now a lot of people end up using it. I'm not against deep learning as such. In fact, I find it perfectly good for problems which, as I mentioned earlier, require some level of over-parameterization or fitting. Right? But at the same time, I think they are very expensive. So in fact, these massive models can be really expensive to train. Hundreds of millions of billions, trillions sometimes, right, of weights which you get trained. So my question is, the first question to ask is, do you need something that complex to solve a problem? And if the answer is yes, by all means, go ahead. Now, let me go ahead with another answer. The other side of the answer is, let me say what you can do, in different fields, right? So, for example, right, you said the question is, how do you choose? Right? There are different types. So, the different types of machine learning exist. Right? So, different types are supervised, unsupervised. There is also the reinforcement, and then there is semi-supervised learning. Right? If you want to, classify it as sort of like, very broadly, these are kind of the forms, right? And the thing is that all of these have different methods which are integrated into them. Now, one thing I would say is that, in terms of, the industrial applications, because I think one of the key things in this meeting or conference is that we are all, data science leaders in industry. And I think the key is to basically ask the question, what kind of problems can you solve? Now, for me, I look at a number of different types of problems that can be solved. So they go from anomaly detection, computer vision, forecasting, cohorting or clustering, right, that we do often, optimization, I know several of you have mentioned that earlier, attribution, a very important problem. So essentially you ask the question, how do you attribute? Causal inference has become a big thing in medical science. I know several of you have mentioned it. And then reinforcement learning, of course, all of your marketing models have just moved to reinforcement learning. Your portfolio optimizations have moved to reinforcement learning. Anywhere where you have an exploit versus exploit, that's where your reinforcement learning comes in. And then, of course, there's a huge domain of natural language processing. So now, the thing is, I could delve into each of these things. Right? The question is, how do I answer this in a more generic fashion? So you take each of these problems, right? There are two key things here. One is, what is the level of complexity that you need? Because it depends on the problem and the need. Right? How large is your parameter space? How much data do you have in time?
Yeah.
How fast is it going state? Right? How fast is the data going state? And how much of those features can you actually engineer by yourself or by the machine? Right? Now, all of these play a role in determining what you should use. For example, right? In finance, very commonly, people end up using SVMs, right? Support vector machines. It's a very specific answer. I don't want to, become a red herring here because I think it's not the only thing that can be used. I know that people will be like, okay, what is he saying? And I'll tell you one thing. So one example is to use an SVM, for example, because it's like fantastic. It's like a asymptotically equivalent to a elastic net with a linear limit. Also can work with very recent data. You don't need too many parameters. Can be, perfectly say refined to actually, go with decent level of parameterization when it's used in conjunction with, say, other feature selection methods. Right. So my general approach to solving any particular problem, right, has been to always, say, cut down the feature space very large. So essentially start off with a very large feature space, do your feature engineering, cut it down using, say, things like a correlation matrix, your mutual information, things like that, and then go ahead with your machine learning algorithm, because you don't want to feed a billion parameters with your machine learning algorithm, right? Because most algorithms cannot take. So that's kind of been always my approach. Now, that's as far as, say, training is concerned, you can use things like SVMs, fantastic, right? Where you have, for example, things like, you want to learn the posterior distribution, you have a lot of data which is covering different parts of the parameter space, and essentially it's not uber complex, right? And you need explainability. Of course, I think Nitin mentioned this, you end up using things like random forests and gradient boosting. Fantastic, right? Random forests even give you like feature importance. Why would you not use something like that? It's so great. Although it's not the most precise feature importance, but it's good enough. It's a starting point. It's fantastic. So I would use that. I am a big fan of random forests. Call me a fool in that sense, but I really like it. Right? And then, of course, you come to the overfitting parameter space, overfitting kind of domain, which is okay with doing that. You have your natural language processing. Fantastic advances have been made with image recognition, with speech, with deep learning. So I mean, the justification for deep learning exists to a tremendous level, right? I mean, I am really a big fan, and I actually end up using quite a bit of it, for GANs and things like that. I like generating art, generating music, things like that. And you can't go anywhere else to do that sort of stuff. Reinforcement learning has completely become the domain of deep learning right now, right? It's like deep reinforcement learning is the real thing. I mean, machines that play Super Mario, which play chess, beat grandmasters, come on. I mean, what else can you ask, right? So I think the deal is, I've given quite a bit of information here, but my only point is that, being diligent from the beginning of the data exploration process all the way to the end is key to understanding what should be used where. And I hope that kind of gives you a picture of what I'm trying to convey.
Absolutely. Thank you. Doron, moving to you, from your point of view, how do you become a data-driven enterprise? What ignites it? Where do we start from transforming into a data-driven enterprise? You know, we talk about AI and so on. I'd love to hear your view about it.
So I think it always starts with a strategic imperative. I think customers today expect a amazing customer experience. We at ING have a strategy to try and create a differentiating customer experience. It is simply impossible to create a differentiating customer experience without the use of analytics at the very least, going through to AI. Because most of the experiences that people have today, whether they in search or on social media apps or on different e-commerce apps in their private lives, are incorporating subtle intelligence, and seamless journeys that are only enabled with the use of AI. So, there's simply a strategic imperative today, and in order to get it moving, you need that strategic imperative. I think next to that, you of course need a strong leadership that actually buys into that. We've been very lucky at ING, for instance, to have leaders who have said we are going to invest in new technology, new skills, and we're going to try and bring those technologies and those skills to the business and to our customers. So I think that's critical, strong leadership. I then think you need to make it as concrete as possible. So you need to get pretty tangible pretty quickly. I think a lot of PowerPoints and a lot of processes and a lot of talk will not will get you some of the way, but will not truly gain momentum. And then following that, I think you really need to have the different ingredients working together to scale that. And I've alluded, previously that you need to have the people, the processes, the technology in place, and that needs to happen, at an equal pace. You need everything to work together, because you cannot place a data scientist alone in a context and expect them to do all the things necessary in order to bring a model to production. There's a lot more skill sets and processes needed, and of course you need to have your house in order as well from a risk perspective. So as a regulated institution, it's crucial that our customers are safe and secure at all times, and that we are ensuring that our data and our customers' data is safe and secure at all times. And so it's imperative that in that scaling process you have those guardrails in place, because the easiest thing you can do is stop innovation. The worst thing you can do is let innovation go unguarded from a risk perspective. But most of the projects and most of the process fall somewhere in the middle. So you have to have, a well-organized environment around that. So I think those are the ingredients you really need to bring things to scale, at least in my context.
Thank you. Following about that, Sanjeev, if you can help us looking into the future about some of the challenges in processing big data and machine learning models, look into the future. The more we're doing it, we talked before about scale. So some of the challenges or problems we should be looking at moving forward.
So certainly, I would like to pick this question in two perspectives. One is the business side, and the other is the AI/ML strategy that we want to apply, right? So there are multiple governance steps or government regulatory changes which also impact the kind of models. For example, if you're talking about autonomous cars, right, and who takes, and I think David was also talking about security and who claims the responsibility of an autonomous car making an accident, right? So who claims the responsibility, who should be held accountable, right? So these are the kind of governance rules, and what are the regulatory challenges around the use cases or the solutions that we build using AI/ML. Now, also we have to look at the competition strategies which are changing. And also I thought I should be talking about data monetization here, right? Because see, privacy is certainly an important part that we have to do. We have to make sure that the privacy is maintained for the customer. But at the same time, data and the behavior of a behavior that is captured through the data, right? If I say without telephone number or without customer ID, if I can share the rest of the attributes to an ecosystem, I think a lot of cancer patients can be saved then, right? So because the attribute, the data, the images, if I'm talking about the images, if I remove the customer identification details from there, the images can then directly help me understand whether or not a person will have cancer or not. Basis certain CNNs that I apply on top of the imagery data that is gathered, right? And this data can range not only within a country, right? We can accumulate this data from the whole world, right? And then the challenges that you are talking about now today, if we look at the capacity that we currently have from cloud, see, the major problem was storage, processing, right? Integration of end-to-end pipeline from the touch point, right? If I want to push any intelligence to an edge or push an intelligence to a mobile or a end destination, that was a challenge. But now that those things are getting corrected with different kind of connectors and APIs which are now available, right, to actually process the data, trigger the inference, and then push it back to the end user, right? Whether it is an enterprise or a consumer, the intelligence is pushed there. Now, if I look at the challenges, let's understand the volume of data, how that volume is going to increase. I told you about the 5G, which is capable of giving 4.2 Gbps. That means 4 GB, over 4 GB in a second, right? That's a large volume of data. Now, volume of data is going to explode. How do we make use? How do we store this data? How do we process this data? Becomes a challenge. Now, when we talk about data, there are multiple type of data that we have. That is a customer usage behavior, billing behavior, or structured, unstructured, and I saw social media data, or the video data, or the imagery that is accumulated through these networks, right? So intelligence will also be based on what is the decision support an image can provide me, right? Looking at an image, can I give access? If I build a face detection application, can I accurately identify a person, right? And then give access, right? If I want to build an alert system, burglary alert system, can I make that? Can I put that edge device on top of in front of my house, so that a camera itself will be able to make a decision whether the person knocking the door is somebody suspicious or is a little unfriendly, right? So that kind of information can then be pushed back to my mobile, or a consumer's mobile, or a subscriber's mobile, saying that somebody is knocking at the door, which is quite suspect, not normal, right? Right. So those are the kind of problems. Then we also have to look at so conventional. So I think Sidharth talked a lot about different conventional algorithms that are currently used, right? So SVM, ADA boost, or linear regression, logistic, and so on and so forth, right? We also have to understand that the algorithms are getting updated, right? So every day new statisticians, or there is an upgrade to the neural networks. The deep learning is increasing now, because as Doron rightly pointed out, that most of the intelligence would go towards social media data, unstructured data, and video analytics data. That is silent, that is true. What can be seen can be sold, right? And that's why if we can inference from the image or a video and send that intelligence, for example, if I have installed a camera, IoT camera, a visual sensor camera at I Square, right, where a lot of traffic is there, it will be able to count and send back the report to a traffic police center, right, saying that this is the kind of congestion which is happening in different nooks and corners of a city, right? So traffic planning can certainly be achieved, right? If some kind of procession is passing through a particular area, if these images are able to, cameras are able to capture those images and send to the nearest police station saying that yes, there is a procession which is going on, or there is a congregation which is happening, right, and which is not normal based on the previous learning of the model, right? So the entire ecosystem becomes little more intelligent, intuitive, and the models also become self-learning, right? So these kind of images, whether or not it was a peaceful procession or it was a violent activity which was going on in a particular area, can then be fed back as a reinforcement learning, as an images or different kind of voices, noises that we capture in form of cognitive form. Because ultimately, how do we feel, how do we connect, or how do we understand any event, is because of different perceptions, right? We see, we touch, we listen, we do different, we take different data sources in mind, and ultimately AI is mimicking the human behavior, right? So similarly, we would like to have a image coming in, the voice coming in, the kind of different kind of inputs that we can get, right, to make a inference. I think these are the challenges that will be there. And certainly then we talk about the real-time analytics, or real-time inputs that we want. And that's why there is a concept of edge analytics and not processing on the cloud. So that's why can we have these kind of applications running at the edge itself. And the intelligence at the edge itself can be, so for example, if a person wants an access in office, camera should be able to decide whether or not the person is genuine or not, right? Instead of that image goes back to cloud, the authentication happens there, and then there is a signal coming from there. If there is no network, then there is a failure, right? And similarly, chatbots working offline, online, on the cruises where no internet is there. So there has to be intelligence at the edge, right? So if chatbot is working at on top of some cruise in the middle of the sea, it should be able to work without internet connection, without getting connected to cloud. It should carry that intelligence, right, in form of maybe those pickle objects, so on and so forth. So these are the challenges that I see. And I think a lot of it is getting mitigated over a period of time with these cloud technologies which are coming in to the market. Doron.
Thank you, Sanjeev. Now, thank you. Following on that, I would like us to talk about edge and think about production environments. And Priyanka, if you can help us with some of the risks to AI solutions we need to take into consideration when talking about AI solution for production. Can you help us out?
Sure, Doron. So I know we covered a lot of topics and scaling the machine learning models, etc., in production. So the top 3 risks or challenges that I have seen across multiple implementations is the first one being the capability to reproduce the data across the different environments. So the data stream, the data structure, the quality, and the sequence of features that is coming in your build environment, when you're trying to build a model, mostly it is very difficult to replicate that and reproduce it in the production environment. So I think even before we actually plan building the model, this is one risk that we carry, and you should work around architectural frameworks to kind of ensure that the data reproducibility is always, that concern is always checked, and we have built guardrails around handling that. So that is one. And the second thing is the infrastructure. So I think Sidharth talked about, and some more people talked about, and Nitin talked about what kind of infrastructure you would actually need, and you need to really think through that before we even start building the model, how much, whether we need the GPUs and or we are, okay with having small CPUs scaling horizontally, and it all depends on the architecture of your machine learning model, whether you have offline prediction model or your model is actually serving as a microservice or you're embedding it in a website, and so on and so forth. So the data reproducibility, the infrastructure scaling or the elastic infrastructure, if we need that based on the requirements, all of this need to be thought through even before we actually start implementing AI solution. And the third most important point, which kind of also talks about the data reproducibility, is the process of continuous monitoring of important parameters like the data sequence and the data quality. So there should be process to monitor that at the inbound as well as at the outbound. We need to measure the bias and accuracy and fairness, and this monitoring infrastructure needs to be in place always, and setting up a feedback loop to kind of tune back the models if there is any change in this, and any change in either in the data quality or the input data, or the parameters like accuracy and fairness and bias. So I think that is the third most important point. So those three risks, if you kind of cover that while designing, while architecting your AI solution, I think we would have covered most of the challenges that we would face, down the line.
That's very helpful. Thank you. Moving on to the discussion, talking a bit about cybersecurity consideration regarding artificial intelligence. I would like to hear, Nitin, is kind of a general question to start with is AI safe? AI and machine learning safe? Considering different risks we see, and we know, there's a lot of talk about cybersecurity lately. What's your thoughts about that? How can we help protect against different risks and threats we see?
Yeah, absolutely, Doron. So a disclaimer before answering or putting my thoughts on this thing. I'm an optimistic guy. Okay, so I believe that AI ML it's a safe technology.
It depends. Approach to cybersecurity, saying you're optimistic.
Yeah, absolutely. Yeah. So I believe that Doron, it's a safe technology, but it actually depends that who is building it and who is actually using it. What's the intent? So when I say that one of the biggest risks in AI ML technology is governance. That what kind of an ethics or practices that you're using. As you can see, Google has published their AI principles. Microsoft is publishing something similar as well. That these are the problems that they will be working, and these are the problems they will not be working. What kind of a governance model that you're going to put? What kind of an ethicist that you're going to actually suggest and add to make your models like what I should say, to remove any discrimination or to remove like any sort of an exclusion. It has to be very inclusive. So it actually depends that yes, who is creating it, but along with that, it actually depends that who is using it. Microsoft published or launched a chatbot with a very great intention, but everybody knows that what kind of a data that users provided, the kind of a things that chatbot actually learned over a period of a time, and it started actually doing very bad things that it was not supposed to do. Adversarial attacks, it's going to improve. If AIML technology is helping us, it's going to help hackers as well. It's going to help spammers and scammers as well. So that cat and a mouse game will always go on. I think we just need to be very careful that hey, how to use this technology. If you're building anything, don't just think about what kind of a things that it can do for like only the good things. Also think like from the black hat as well, that or what I should say, from the weird hat as well, that yes, what kind of a bad things that it can do, how this can be actually used in a way that it is not supposed to be used. Only then launch anything, only then launch any of those solutions. That's why I really appreciate the logic behind OpenAI's like a GPT-3 stance that we will not be making this thing open source because it can be used at some places it should not be. And that's absolutely right. If you're not very well aware of the power of this technology, please, please, please don't use it. Otherwise, overall, in my experience, it's a safe technology.
Thank you, Nitin. David, moving to you. Hopefully, you're as optimistic, but I think I know you better. So I'll ask, actually, following Nitin, if you can help us out with what do we need to take into consideration? What are the specific things need to be protected when talking about AI computing?
Yeah, interesting. Yeah. Well, I am optimistic. I think, by the way, just to add to his previous answer, because it had me thinking about 100 things. It's actually two things. Look, every advanced technology you could use for good and bad. The technology is not inherently good or bad. There's a whole range of policies around it, depending on how you want to use it. I'm actually reading a book about it. It's fiction, but based on truth, AI in 2041, it takes you through scenarios of how it may actually be used. And it really depends. It could bring on new kinds of jobs. It could take away jobs. Privacy, it explains how AI may be used to monitor literally in China versus might be used in the US. And it's totally different, level of monitoring of people movement that you can control and do social engineering versus not. So it's really strictly depends, I think, on policy more. That's my 2-second thing on that. The other thing about as far as protection, from a pure cybersecurity perspective, I think there are things like, one, you have to obviously protect the model itself. You can, get to the model, make some code changes and cause some serious problem, but also the data. There's a lot of activity, people going on to say, well, let me change some things in the data that would cause problems. Kind of a simplistic example, but highlights it. Let's say, self-driving cars, automation, and it's monitoring and there's a crash up ahead. You can, if the crash is, 10 feet in front of you and somebody's modifying, the data and says, hey, it's 100 feet in front of you. Well, that's going to be a pretty big difference. By the time you get the response, you've already crashed. And there's a lot of things you can do to change the data. So you've really have to, from a security perspective, protect the information as well. Even from, we think about how do you distribute the model. So if you have federated AI and the model gets out there, how do you store a copy, sign it, store a mask, sign it, securely distribute it, authenticate it when it goes out there. So you're actually distributing the same model somewhere, and it's not a hacked model that's being intercepted. Again, we talked earlier about even, collaboration. And those are kinds of things. How do you protect the privacy? So one, there are rules. We've joined this group, Alliance for AI and Healthcare, and there's actually 2 working groups. Again, one is dealing on policy of data sharing, and one is dealing on the technical implications on how do you protect the privacy depending on the policy. And there are some people who think, we've gone too far protecting some of the data because there's massive advantage. If you could collate all the information about COVID as the most obvious example,
right,
you could get a lot more information, but how do you share that? And then you have privacy implications. And that's why there's one working group working on the policies and the other one working on the technology behind being able to share the information. So I think there's a range of aspects, and those are kinds of some of the things, in a relatively brief supply that I think we need to consider about when we protect AI. And the better we protect it, the more optimistic I get. At least that takes away a whole sphere of attack and distrust that would go on, at least if we protect it from that perspective.
Thank you, David. Following that, especially talking about privacy in different systems, Doron, I would love to hear more from you about how do you see it, maybe in your experience or the organization you work with, about the balance between data privacy and innovation when working with artificial intelligence and analytics in general?
Yes, so look, a lot of the points I think have already been covered. I think I can tell you a bit about how we do it. I think it's a lot, you are dealing with, as much as we talk about technology and AI and machine learning, at the end of the day, it's got a lot to do with how people handle data. And, that's got a lot to do with values and with policies and restrictions. So I think it's important, and we do that, educate people. We use the principle called the 10 commandments of data and how we act with data in an ethical way. I think it's also important that you have the mechanisms in place within the organization to discuss dilemmas, and that you have a culture which enables people to expose dilemmas and feel that those can be thoroughly discussed. I said it's always easy to say no. It's more difficult to say yes, but you want to say yes with a thorough process and thorough due diligence. I think by and large, in most instances, the de facto outcome is ask the customer. So if the customer has explicitly enabled you to use data for a specific purpose, then it's your job to adhere to that purpose in a very unwavering way. And if the customer has not given you approval to use data for a specific purpose, then you shouldn't do that. And I think that when in doubt as to any ethical issues around the use of data, simply don't do it. I think if you look at say going more to the exposure of machine learning algorithms to different security risks, I think then you go to, for instance, poisoning data, where someone infiltrates and poisons your data, or you go to, for instance, where someone uses some kind of method to abuse your model in order to re-educate it. So you get prediction drift and that kind of thing, which leads to different outcomes. I think I haven't seen that. I've read about it more recently as a new domain of security, but I haven't really seen anything specific about that. Definitely not in our organization, and no announcement from other organizations that I'm aware of.
Thank you. Since we're kind of running low on time, I would like another question to go back to David. We mentioned a few in the discussion. We mentioned Edge and the opportunities Edge brings with analytics, and obviously with AI. As we know, with new technology, there's always new challenges. Can we talk about just really briefly about AI and Edge and the security challenges we see there?
Yes, so there are certain things. First of all, by edge means a range of things. So let's assume kind of the things are closer to the far edge. And there's an example. There's a question that even came up about how do you get processing power and stuff at the edge. And some of the challenges by itself is a lot of times at the edge by definition is not necessarily secure. You may be putting it in a sports stadium, you may be putting it near a farm, you may be putting it on a factory floor. It may or may not be, it may be isolated in and of itself. And so the concept is almost, and how do you do this easily? The concept is almost, how do you do almost a secure data center in a box? How do you just take everything and be able to get all the processing power and all the security inside of one environment? And I know this was kind of a leading question because it's kind of, as one example, it's kind of what Hub does, actually from that perspective. And everything sits inside of one thing. So you might have everything from the root of trust through the access, through the processing power in one thing, but now you have to protect it. And when you go about doing that, there's a whole new kind of computing paradigm to even increase the perspective, dealing with kind of confidential computing. So you want to protect the data as it's in transit. You also want to protect it while it's sitting there. And another area of really extreme vulnerability is the next stage is how do you protect everything while it's running at the same time? And that gets into a whole range of adding confidential computing to it. So you need the whole range of capabilities. One of the things we take a look at slightly differently in a confidential computing is we look at the entire computing stack. So when we look at when I say a computer center in a box, we look at how do you secure everything from the hardware that's sitting there. Maybe it needs to be, the whole box needs to be tamper-proof because it's sitting in an isolated environment. The actual circuit boards, how can you not break in through there, through the BIOS, taking a look at the virtualization layer, through the application, through the data. Every single piece in that stack kind of needs to be protected as well while it's running. So once you start protecting everything from the external hardware, tamper resistant, all the way through the data in one place, you start to look at, as I said before, almost kind of a computer center in a box, and you could add various degrees of computing power as long as you could place it in various locations, and you have that ubiquitous computing power. And that's what's happening, is all of these kinds of computing power is really moving more and more to the edge. And what you're going to see is a lot of these kinds of security capabilities to protect it as well, because they don't always have the benefit of sitting behind in an extremely secure IT environment. They're sitting more out in the open more, so that they need to be self-contained as far as the security is with it at the same time. So hopefully at a high level that kind of clarifies it a little bit quickly. And back to you, Doron.
Thank you. So I would like, before we move to the Q&A, I would like to say thank you to everyone for their insights and really wonderful discussion. Obviously, we dig, in some things we went deeper than others, but I think in our discussion, it's a really good taste of the subject. But very fascinating, and the more I read about AI and following this discussion, I'll definitely do some more reading. There's a lot to learn, and there's a lot of aspects to it in different industries. I hope the audience also found this very useful. And there's a few questions we can answer from the Q&A. And one of the things we saw is that the question that came from is, do you see any privacy issue with AI and machine learning, especially with face biometrics? So we did speak about privacy, but on face biometrics, does anyone want to take a go with this specific question?
I'll
David?
I'll start, and I know there were others, from their perspective. I mean, in a way, we did touch upon that when we talked about the optimism of the trouble, but the issue comes down to there's both a technological thing, that the technology needs to be able to support the privacy, to say, stop people from getting it and making sure only the people who actually need it can, whether you're sharing the information or it's just for an individual. The other aspect is the policy stuff, is what are the policies, and the biometrics and face recognitions, you will definitely see in different societies people having different policies. And so the same AI will both have the capability of protecting your privacy and not protecting your privacy. And I believe a lot of it is going to come down to making sure the enabling technology is there, and then a lot of discussion on the policy.
Thank you, David. I see we had an earlier question about ecological impact, and I'm guessing in some cases AI can improve procedures and so on, but there's a question about ecological impact, about and big data. Does anyone want to take a go at that?
I can take a stab on for that particular ecological impact. So I believe that these kind of problems are the modern day problems. So definitely these are the challenges. We want everything personalized. We want processing all those kind of large data. We want one of the best recommendations. We want all the support from machines, but we are not ready to pay the cost. So I believe that nobody actually envisioned these kind of challenges that might come. Definitely, there was some options or some solutions that few of the companies came out with. Microsoft tried this project Analytic, where they actually submerged a small data center into the sea and tested out that yes, if that will be more ecological and it can perform at exactly the similar kind of performance as that of a data center on ground. So it became a successful experiment. I believe that this day before yesterday, they updated some of the metrics that yes, the total number of failures are almost 1/8 of a similar data center on the ground. I believe some more innovative solutions might be coming up so that the overall impact on the ecology will come down. I believe that right now the concept of big data has gone away. There is no more big data. people have started already talking about the quality of data. So that we do not need lot of the data to process. So I believe that, okay, moving forward, the low data will be needed to build new models, and all the requirements to store all the data, processing those kind of a large models, those requirements will go down. So there's a lot of research going on. So I believe that, okay, in a nutshell, things will improve.
Yeah, that's again very helpful, and I think it's also about balances. This has been a really interesting discussion. We are even beyond our time limits, but this is what happens with great conversation. I think for sure we need another discussion, and very much would like to see all of you join us in one of our next discussions. I'll summarize and say this was not only interesting, I think, only for the audience, but for me personally. And you would be able to find this full discussion by next week on YouTube and on LinkedIn channel. And you can find, for any other question, you can follow up with hubsecurity.com on our social channels. I'd like to personally thank each one of our speakers today. Thank you for contributing to the discussion and joining us today. Priyanka, Doron, Sanjeev, Sidharth, and Nitin, this was an absolute pleasure. Thank you very much. And thank you for the audience who stayed with us and we're here for this discussion. Thank you very much, and I hope to see you all next time.
Thank you.
Bye. Thank you all.
Thank you so much.
Thank you, everyone.
Bye-bye.
Thanks, everyone.